Good morning, my dear students. My name is Anjaneya Sharma, working as physics lecturer in one of the reputed institution. Today, our concept is about electric dipole. So, important concept for intermediate exams and also for all other competitive exams like NEET, EAMCET, mains. Okay, so electric dipole is also very important concept. Okay, for all exams, mainly it is useful for inter. Definitely you will be given one 4 marks question. Now about the concept is electric dipole. Dipole means two poles. Electric dipole means a system of two equal and unlike charges like negative, positive. Okay, two equal and unlike charges are separated under certain fixed distance is called electric dipole. Okay, so one negative charge and one positive charge are standing at some distance. Okay, so that is called electric dipole. But due to force of attraction, repulsion, the distance between them varies and it will be standing at the same point called equilibrium. No? So, electric dipole is a system of two equal and unlike charges separated by certain distance. Okay? Now, about its dipole moment. So dipole moment is denoted by letter P. Okay. So how you define dipole moment? It is the product of either charge, means positive or negative. Direction wise changes but magnitude wise you only know. So product of either charge and length of the dipole. Length means distance from negative to positive or else positive to negative. So that distance denoted by letter 2A and charge Q. Okay, so dipole moment is defined or measured as product of either charge into length of the vector. Okay, so nothing but it is also a vector. Okay, units. Charge units you all know, coulomb. No, length units meter. So its units are coulomb meter. Okay, so dipole moment is defined as the product of either charge and length of the dipole, and it is a vector quantity. Its units are coulomb meter. Okay, so now we are going to know electric field strength or electric field on axial line of a dipole. So very important question, IP point of view. Now let us suppose there are two charges, minus Q plus Q. So two equal charges of opposite are separated by a distance 2A. So the line joining negative and positive charge is called, this line is called axial line. So what do you mean by axial line? The line which passing through negative and positive charge of the dipole. Okay, so now you choose a point, say P. Okay, select a point P on the axial line of this electric dipole. Okay, so you want to know now strength of electric field. So the concept is strength of electric field. Okay, So electric field strength on the, okay, on axial line of an electric dipole. Okay, so electric field strength on axial line of dipole we are going to calculate now. So remember, wherever you are going to calculate strength of the electric field, there you always imagine one unit positive charge. So here a unit positive charge is considered. So you know this positive charge, no, repel this positive, at the same time attracts this negative. That means there will be attractive force and also a repulsive force. Say this point, so this point is at a distance, say r, from the midpoint of dipole. So we can come to a conclusion that this positive charge, unit positive charge, attract the negative one, repel the positive one. So repulsion, no, so direction will be taken outwards. Attraction, direction will be taken inwards. So first I am going to calculate strength of electric field, okay, due to this negative charge. Okay, you know 1 by 4 pi epsilon naught into q by r square, distance square na. So already from midpoint to this distance is r, and you know the total length of the dipole is 2a na. So a plus r whole square. Okay, so 1 by 4 pi epsilon naught into q by r plus a whole square. Okay, so that is strength of electric field due to negative charge. Now due to positive charge, so you know strength of electric field, okay, due to positive charge, 1 by 4 pi epsilon naught, right, into q by r minus a whole square. Because you know this total distance is r, you want only this particular distance. That means r minus a will give you strength of electric field due to positive. So you know the positive strength, electric field strength due to positive will be more than negative, because you see r minus a, less distance corresponds to more strength, no? So that is why net strength, okay, net strength at this point is equal to positive minus negative. Okay, now you know E net is equal to, so if you notice, you know q by 1 by 4 pi epsilon naught is common, no, in these two. So I am taking directly q by 4 pi epsilon naught common. Okay, so 1 by r minus a whole square minus 1 by r plus a whole square. Okay, so further if you simplify, a minus b into a plus b na, so you can write a square minus b square whole square, right? So minus, no, so it will be divided by plus times, plus, no, divided by minus times. Okay, so when you expand these two in the form of a plus b and a minus b whole square, no, so a square b square, r square a square gets cancelled, no, so you will get 2ab together 4ab, right? So which is equal to, you can write q by 4 pi epsilon naught, right, 4a r by r square minus a square whole square. Okay, so you all know dipole moment denoted by letter P, which is measured by, you know, product of length and charge, no? So instead of 1, 2a and q, you can write dipole moment, right? So 2pr, because 2aq taken as p, right, by 4 pi epsilon naught into r square minus a square whole square. Okay. Now dipole means two oppositely charged of same magnitude or separated under small distance. That means it's very clear that A is the one which is very small. Then A square too small now, it will be neglected. Okay. So if you are neglecting this A square now, you get electric field strength. Okay. So 2pr by 4 pi epsilon naught, okay, r square whole square. Okay, so 1 r gets cancelled. Okay, so you get 1 by 4 pi epsilon naught, right, into 2p by r cube. So this is the because only 1 r is cancelled now. So electric field strength on axial line of a dipole at a point is given by 1 by 4 pi epsilon naught into 2p by r cube, where p dipole. Now we are going to calculate strength of electric field, okay, on equatorial line of a dipole. So dipole means two opposite charges are separated under small distance, right? So here you have taken negative positive separated by distance 2a, and magnitude of each one is q, minus q plus q. Now about equatorial line. So equatorial line means the line which passing through midpoint of the dipole is called equatorial line. Okay, so select one point P on this equatorial line. Okay, so already in order to calculate strength of the electric field, you should always imagine one unit positive charge. So this is one imaginative unit positive charge. So positive, so that is why the direction will be taken outwards. But positive, negative, so the direction will be taken inwards. Right? So first you have to calculate strength of electric field due to negative. So 1 by 4 pi epsilon naught, right, into q by distance square. So this total is 2a now, means this is a, this is r. So this will become root over a square plus r square according to Pythagoras theorem. So root over a square plus r square. So formula of electric field 1 by 4 pi epsilon naught, right, q by r square now. Okay, that is due to negative. Next, due to positive, 1 by 4 pi epsilon naught, right, q by this distance square. Of course both are at same distance, so that is why root over a square plus r square whole square. Okay, so this is due to positive and this is due to negative. So this is the direction of resultant electric field due to negative. This is the direction of resultant electric field due to positive. So if you resolve this into two components, horizontal, vertical, its horizontal component is along this direction, means resultant direction. According to parallelogram law of vectors, if two vectors are inclined at an angle theta, diagonal gives the resultant. This is the resultant, So in the resultant direction, horizontal component of positive one is added. At the same time, negative one is also added under resultant. That means resultant field strength along the diagonal direction, no, is given by due to positive and due to negative. No, that is only the horizontal components are added. No, only the horizontal components of positive one and negative one are added. That means, E cos theta due to positive plus E cos theta due to negative. Now gives resultant strength of electric field, no, on equatorial line. Okay. So if you notice, only direction wise they are different, but charge and distance are all same. Means due to positive or due to negative is same. No, say some constant E. Okay, so it is 2E cos theta na, resultant electric field strength is given by 2E cos theta. No, it is nothing but 2E cos theta. Okay, so 2 into electric field strength. So it is 1 by 4 pi epsilon naught, right? Q by R square plus A square. Root cancel now. Into cos theta. So this or this same now. So from here, if you are considering cos theta, this is A. This is distance. No? So cos theta is equal to A adjacent by hypotenuse. It is A square plus R square. Okay. So electric field strength, for our convenience, you can write E equatorial. Okay, is equal to length into charge. Now, so dipole moment is always length into charge. Now, so 1 by 4 pi epsilon naught, okay, into dipole moment, okay, by root over R square plus A square. This is power 1 by 2. And no, so nothing but 3 by 2 power 1. And this one A square plus R square whole power 1 by 2 now. So whenever bases are equal, powers are added, 1 plus 1 by 2. Nothing but 3 by 2. But dipole means very small distance it is having, right? So that is why this A square part you can neglect. So thereby this square also cancelled now. So 1 by 4 pi epsilon naught, right, into P by R square whole power 3 by 2. 2 cancelled, you will get R cube. Okay, so on equatorial line, strength of electric field is given by 1 by 4 pi epsilon naught, right, into P by R cube. Okay, this is strength of electric field on equatorial line. Now we are going to calculate electric field at any point, okay, due to an electric dipole. So let us consider a dipole, okay, negative, positive, separated certain distance, say 2a, distance of separation. Magnitude of each charge is Q. Now you are going to find the electric field strength at an angle theta. Okay, at an angle theta. Then this dipole moment P, resolved into two components, horizontal, vertical. Horizontal component P cos theta vertical component P sine theta. Now along this direction, field strength, say E1. So this is E1, this is E2. So along this direction, 1 by 4 pi epsilon naught, right, into, it is axial now, so that is why 2p cos theta by r cube. Okay, 2p by r cube along horizontal direction you are taking, so that is why it is p cos theta. Okay, so strength of electric field along this direction is given by 1 by 4 pi epsilon naught 2p cos theta by r cube. Now E2, okay, along this direction, it is similar to electric field on equatorial line now, so that is why it is p sin theta by r cube. So this is p sin theta by r cube, this one 2p cos theta by r cube. Say two forces E1, E2, so two fields E1, E2. So you want to know the resultant strength at this point. No? It's root over E1 square plus E2 square. No? So 1 by 4 pi epsilon naught, right? R cube 2p cos theta whole square. This one 1 by 4 pi epsilon naught p sin theta r cube whole square. So if you notice, this 1 by 4 pi epsilon naught r cube are common now, so you can take them out. 1 by 4 pi epsilon naught, okay, p by r cube whole square root. Cancel now, under root. Now only 2 cos theta whole square is left. Plus this one, sin theta is left, right? So, electric field strength at any point due to a dipole is given by 1 by 4 pi epsilon naught, right, into p by r cube. Okay, this is 4 cos square theta now, so I can write this as 3 cos square theta, okay, plus cos square theta plus sin square theta. Instead of this I can write 1 now. So electric field strength at any point due to a dipole is given by 1 by 4 pi epsilon naught na into p by r cube root over 3 cos square theta plus 1. So if you remember this formula, at any point you can find. For example, you want to find on axial line, theta can be taken to 0 now. If you want to find on equatorial line, take theta 90, or in between at any point also you can find. Okay, so electric field strength at any point due to this dipole is this formula. So if you want on axial, take theta 0. If you want on equatorial, it is on axial. On equatorial, take theta 90 degree. Now, there is one dipole held in the uniform electric field. Okay, so there is one uniform electric field. Uniform means everywhere strength of the field remains same, right? So field strength, say E. So in this uniform electric field, suppose you are placing a dipole at an angle theta. Okay, so a dipole is held in the uniform electric field. Okay, so thereby this negative charge as well as positive charge both gains force. No? So in the previous classes, force experienced by a point charge when held in the electric field, right? So force experienced by negative is EQ. Force experienced by positive is also EQ, because it is uniform electric field now, so that's why everywhere strength remains same. So when you are placing the dipole in the uniform electric field, both positive and negative charges gains equal force in opposite direction, which makes the dipole to rotate some angle. That is nothing but torque. So we are going to calculate torque, okay, experienced by dipole when held in the uniform electric field is equal to force of either negative or positive into perpendicular distance, right? So force experienced is EQ now, so tau is equal to EQ into perpendicular distance. So this is perpendicular distance, right? So from here, if you are considering opposite by hypotenuse, now sine theta you can take now opposite. Okay, so this part A and I am taking. Say this is A, B, N. So A N. Okay, from here I am taking. So A N is the perpendicular distance. By hypotenuse, length of the dipole now. So 2N becomes 2A sine theta. Okay. So length into charge gives dipole moment denoted by letter P sine theta. So tau is equal to P sine theta, where E strength of the field and P dipole moment. Suppose you want to know maximum torque gained by the dipole when held in the electric field. So if you place at right angles now, theta becomes 90 degrees now. So thereby the maximum torque is equal to P. Okay. So suppose you want to know minimum torque. So whenever you are placing the dipole along the direction of electric field, so in that case theta taken 0. That is when you are placing the dipole along the direction of electric field. Okay, theta taken 0, sine 0, 0 now. So tau minimum is 0. Force between two dipoles. Okay, so let us suppose there are two dipoles. Okay, two dipoles. One of dipole moment say P1, another one of dipole moment say P2, or taken parallelly. Okay, separated by a distance r. Then the force between them is given by 1 by 4 pi epsilon naught 3 P1 P2 by r power 4. It is a repulsive force because both the dipoles are taken along the same direction. Now suppose if one of it is reversed, then same magnitude of force is treated as attractive force. That is if one of the dipole is reversed. Okay, this is when two dipoles of dipole moments P1 and P2 are placed parallelly with separation r. Okay, now suppose if two dipoles are taken side by side separated by some distance r. So if two dipoles are taken on the axis separation r, then you know force given by 1 by 4 pi epsilon naught, right, into 6 P1 P2 by R power 4, because you know over here you are calculating strengths on axial, no? So axial strength will be more than equatorial, that is why it is 2 times. Okay, so force between them is given by 1 by 4 pi epsilon naught, right, 6 P1 P2 by R power 4. Okay, now suppose there are two dipoles. Okay, two dipoles inclined at an angle theta. Okay, inclined at an angle theta. So plus q minus q, plus q minus q, inclined at an angle theta. So two identical dipoles inclined at an angle theta, then you know the resultant dipole moment, okay, is given by, you know, p square plus 2p square cos theta now. So you can take 2p square common, 2p square of 1 plus cos theta, no, it is a quadrupole, right? So 1 plus cos theta, you can write 2 cos square theta by 2 na, minus 1 cancelled, right? So resultant dipole moment in this case is, you know, 2p cos theta by 2. So whenever two dipoles are inclined at an angle theta, the resultant dipole moment is given by 2p cos theta. So if you like this video, please subscribe, like and share, so we can try to give you more and more information related to physics part. Thank you.